let us continue our discussion on the linear discriminant. So, let us see this picture. So, I have two classes, I have marked them by red and blue points, and these blue classes have a y value, these blue classes have a y value of plus 1, and the red classes have a y value, sorry, it is the other way around. Sorry, I have marked it the other way around, minus 1. I will introduce. So, if we recollect, in our last discussion we said that W1 x1I plus W2 into x2I plus B should be greater than 0 if yi is plus 1 and W1 x1I x2I plus B should be less than 0 if yi equal to minus 1. I think for all of you it is clear. So, what I am basically meaning is that I should pick up a value of W1 W2 B such a way that if I pick up any point whose class level is plus 1, y is plus 1, it should be on the non origin side. That means, it should give this value to be greater than 0. So, if I pick up any of this red point and compute, plug in the x1 y x2 value here to this value of W and B, I should get positive, it should lie on the positive side, which will happen only when it lies on the positive side. Similarly, if I pick up a blue point which has y equal to minus 1, it should give a negative value. Okay. So, what I actually want to say is that if I look at the sign of this quantity, positive or negative, that should match with the class level. If I call that as f x, sign of this, that should match with the class level. So, in general I am writing here x1, x2, in general there can be more components. So, there can be x3, x4, x3, d dimensional, anything it can be, right. So, let me introduce a little bit of vector terminology. Let us say the input vector is like this, and I call something as the weight vector or W vector, which is nothing but each of these weights. Then another way of writing this equation zero is this. You see, if you take the W vector, in this case for 2 dimension there will be only this much, x will be only this much. If you take this 2 dimension, then this is nothing but the transpose of the W vector into the x vector. Okay. So, I can write down this as W transpose, W vector transpose into x vector plus B equals 0. Okay. So, that is the format I have, convention I have used in denoting this line, Okay. So, what I am supposed to do is to find out a value of W, find out a value of B, it gives you a good discriminant. Okay. So, let us see how to do that. So, up to this is clear, this vector notation and origin side and non-origin side. So, let me see what I do next. What I do next is the following. I combine these two as a condition. Sorry, not this. I combine these two as a condition. I say that find so, the first condition I will write down will basically tell that all plus y are in non-origin side and minus y are in origin side. So, I will tell the first condition on W and B requires that okay. If you just look at it carefully, I can in fact combine these two into one single condition, which says that the sign of y and the sign of this quantity should be same. Let me write that down. And this should hold for each and every xi. For each and every xi, this should hold. Okay. So, let me see what this means actually. Let me draw the picture again and tell you. W is the weight vector, x is the data vector. This actually means that all positive points should lie on one side, negative point. So, this line satisfies this line. Suppose I take some other bad line like this, which is not separating. This will not satisfy this. These points will fail. For all points, it will not satisfy. Okay. So, this is sorry. Don't copy this. Write this down. This is the condition. Sign of yi and this quantity should match. Okay. So, this I will call as condition 1. So, what it says actually, the lines the points I have plus and minus point, they put some constraint on what are linear discriminants that we can choose. What are linear discriminants I can choose, okay, so that it correctly classifies. So, but now let us look at one thing. Okay, fine, I want to satisfy that. So, I basically ask you the question that how many lines you can draw, so how many W and V values you can pick up, so that this condition is satisfied for all the xi's given in the training set. Let us see. So, this draws satisfies definitely correct classification, this satisfies, this satisfies, this satisfies. There are many lines which satisfy. In fact, provided provided they are separated. If they are separated, I can actually have infinite number of lines which satisfy this. So, what I want to do is to sort of pick up one of this infinite line which I consider as good. Let us see how do I pick up one among this infinite line. Let me again draw it to make things clutter free. So, you can imagine there are many infinitely many lines like this, many things I can draw. I have to choose one. So, which one will you choose? Which one will you choose among these possibilities? Maybe your answer will be the one that passes through the middle. Okay. Why? Let us see. Why you are wanting to choose that? Let us compare two lines. One passes through the middle. I call it as W1 transpose X, B1 equals 0, and another just touches. Call it as this is L1, this is L2. Okay, maybe I drew it slightly bad, maybe this point is not there, that does not touch. Similarly, these points are not there. Okay. Of course, you will say that L1 is preferred over L2, the middle line is preferred over this just corner kind of line. Why? Both of them are correctly classifying, both of them are satisfying condition 1. If you remember condition 1, both of them are satisfying, one side, other side. Why this is better? Why L1 is better than L2? The answer is, for these given points they are fine, but our goal is to classify a new point. Okay. So, suppose I have a point like this, a point like this. Okay. So, L2 would put it into minus class, which is wrong. This is most probably plus class. Whereas L1 will still put it in a plus class, which is correct. Okay. So, okay. Even though on the training set they are equal, on a test set L1 is better, the middle one is better. Okay. So, let me try to quantify or see what is the quantity which L1 is better, in terms of which L1 is better than L2. Let me draw again. I hope I am not boring you with this repeated redrawing, but really it will help. Okay, it's the same old picture. One line L1. I define a quantity called margin of a line. Define a quantity, I will define it. What is the margin of a line? You take the closest point to that line. How do you find out the closest point? Drop perpendicular from every point to the line. See which point has the closest smallest perpendicular distance. Let us say this point has the point. Okay. That perpendicular distance is the margin of a line. So, you will let me redraw again. 0, and so the margin is, take the closest point, drop a perpendicular, and this perpendicular distance I call margin M. So, let me define. Clear? Okay. So, if I, it is very easy to write it mathematically. If I take a point x I, can you define what is the, do you remember what is the perpendicular distance from x I to that line? Let me call it as d I. From a point x I to a line w transpose x plus b. It is w1 x1 plus w2 x2 plus b, absolute value of that, positive value of that, divided by this is the perpendicular distance, and margin is nothing but the maximum minimum of this overall I. Okay. Now, you see that the center line, now if we will consider the margin, say the corner line will have a much smaller line margin than the central line. So, basically I want a line with a high margin, I want the line with the maximum margin. Okay. So, I stop here today. In my next class I will explain how to get the line with the highest margin, which will give me the equation of the line. Thank you.